Hello everyone, welcome back. The first thing we're going to do in this video is go over the follow-up questions from Monday. So make sure you have them done already in a pencil, pen, whatever it is. And then if you can correct them in a different color, that would be ideal. We want to make sure that we can see the difference between your work and your corrections and that you didn't just copy it down with me the first time you saw it, okay? So this is learning from your mistakes. Hopefully you don't have that many, but it's okay if you do. We always learn from our mistakes. So the follow-up questions in blue is what I wrote after I wrote the follow-up questions. So blue are my answers. So if you want to hit pause and just take a look and write down what I have down if you don't have it. I'm going to highlight a couple things that I want to point out to you. These are just your definitions from the notes, so those should be pretty straightforward. Make sure you realize that a common difference is adding or subtracting. Usually difference means subtraction, but in this case it just means the difference between two. It could be adding or subtracting. So that would be with an arithmetic sequence, and then common ratios multiplying. Okay? Question number 2. You're really looking at this as your work right here. I wrote down some extra stuff. I wrote down, is it arithmetic or geometric? But for this one, your A1 is 7. Make sure you define that. And then, so make sure you have your 7. And then your A of n equals A sub n minus 1. So any number in the sequence is equal to the previous number plus 4. Okay, because these are going up by plus 4. So that would make it arithmetic. Okay, the next sequence was being multiplied by 4, so that makes it geometric. So you define your first number, A of 1 was 1. And then you could either have written A of n equals, you could put the 4 out front. I had to squeeze it in since I forgot it. With parentheses times A sub n minus 1, or you could put it in the back, as long as you just make sure it's sitting right there, okay? And then number 4 was also multiplying. These numbers were going down, so we're multiplying by a fraction of 1/3. Remember the trick. You could take 27 divided by 81, hit math, enter, enter, and then 1/3 will be in your calculator, so that's what we multiply by. That makes it geometric. Your first term was 81, and then you put the 1/3 out front or in the back of your recursive, okay? All right, so hopefully you guys did well with those. Let us know if you have any questions. Today's notes, I have this template for Mrs. Specht and Miss May's students. I'm not sure about anyone else, but we posted this template on WIT, so if you want to print it, it's just the template. That does not mean you don't have to also take notes with us, okay? This just kind of gives you a space out the page and gives you a bit of a guide. All right, so today, Wednesday, May 13th, we're finding sequences now given the recursive formula. So on Monday, you were given the sequence and you had to write the formula. Today, you're going to be given the formula. You have to come up with the sequence, okay? So it's the same stuff. Nothing new today, really, just a different way of looking at it. So we have to review some of these terms. The first thing I want to review with you is the recursive formula. Recursive formulas are formulas where each term depends on the number before it, okay? So each term depends on number before it. Okay, which means you have to have the number before it in order to come up with the number after it. You cannot jump to like the 100th number in the sequence without knowing the 99th number and the 98th and so on and so forth. Okay? All right. A sub n minus 1, this is going to be very important today. This means the previous number. Okay, I cannot spell previous number. A of 1 is the first number in the sequence. I can't tell if this is shaking or not. It's kind of driving me crazy. And then A of n is any number in the sequence. Oh my God, I am really struggling with spelling today. One of those days. Okay. Hopefully you're doing better than I am. All right, so this, we're gonna just refer back to this periodically. So question 1, you should know what this says. This says the first term in the sequence is 7. So automatically I like to say, okay, my first number of the sequence is 7. I have a couple more after that. And I forgot to tell you, we're going to be finding the first 4 numbers in all of these sequences. So writing out the sequence is important. I'm going to leave spaces for once I find my other terms. But A1 is 7, and this is the first term in the sequence. You don't have to write these little things underneath. I'm just going to do it for the first one so you can see what I mean here. First term is 7, and this says any number in the sequence is going to be equal to the number before it plus 6. So that means I'm starting at 7 and adding 6 to each number. So you guys, without learning recursive formulas, can do this. Okay, you would just say, okay, well, 7 plus 6 gives me what? It gives me 13. 13 plus 6 gives me 19, and 19 plus 6 gives me 25. If only it were that simple. It is that simple, really, especially if you want to check yourself, but obviously in math we always have to show our work, which I can hear and see the eye rolls and the groans at home, like, oh my gosh, are you kidding me? Of course you have to make it harder, but we do. I'm really sorry. Okay, and it's really not that bad. So the way you show your work with a recursive formula is you always start with the first term, or whatever term you're given. So I'm given a of 1 is equal to 7. Okay, the second number in the sequence. So now I'm writing a of 2. That means the second number in the sequence. Notice it used to say n here, any number in the sequence. Now it says 2. Okay, a of 2 is equal to the previous number, a of n, plus 6. Okay, I'm going to show you one way of why, I'm going to show you why this is considered the previous number. If you are not following in the next minute of what I'm about to tell you, it is okay, as long as you know that this right here, a of n minus 1, equals the previous number, then you're fine. And I'm going to continue doing it this way. I'm just going to show one time. Some kids get it, some kids pick up on this and they like understanding it, so I'm going to show you. All right, so because it used to be an n here, and now I plugged in 2, right? The second term in the sequence. That means I'm plugging in 2 for n here as well. So the second term in the sequence is equal to a sub 2 minus 1 plus 6. Okay? A sub 2 minus 1 is really equal to a of 1, right? 2 minus 1 is 1. So the second term in the sequence is equal to the first term plus 6. And the first term in my sequence we know is a of 1 is 7. So I would just plug in 7 right here. So a of 2 equals 7 plus 6, which is 13. And we know that's my second number in the sequence, okay? This little side note right here, you never have to show this work, okay? This is me just explaining to you. This is like a side lesson. Side note. You don't really have to ever do that again. I just wanted to show you where that comes from, because then I'm going to just keep popping in this is how easy it is. I'm just going to keep putting in that previous number. So if I want to find the third term in the sequence, let's get back to my black. A of 3 is equal to the previous number, okay? And in this case, the previous number is 13, so that goes in here now, plus 6. It's always going to be plus 6. 13 plus 6 is 19. A of 4 is going to be equal to the previous number. Well, now the previous number is 19. That's the number before. So 19 plus 6, and that equals 25. So these right here are the numbers in my sequence. Okay, 7, 13, 19, and 25. This is just a side lesson, okay? You really only need to show this work, this work, this work, and this work. This is just the explanation why, okay? And then always write out your sequence as well. And because we're adding by the same amount, this is arithmetic. Okay, let's do the next one. I'm not gonna show this side note for this one. It's just this is the work I wanna see on your paper when you do the follow-up questions. Okay, so question number 2 says the first term in the sequence is -2. So right away I can just go ahead and pop in a -2 here, and I'm finding the first 4 terms, so I'm just gonna do 4 letters here. And then it says any number in the sequence is equal to the previous number minus 7. So this is my common difference of -7. And my first term is, or minus 7, my first term is -2. All right, so I always start with my A1 is equal to -2. Then I'm gonna do my A of 2. My second term in the sequence is going to be equal to the previous number. So this means previous number. So I'm going to pop that in here. Previous number minus 7. Okay, and if you want to think about it this way, you can think about it this way. A of 3 is equal to, it's always going to be equal to the previous number minus 7. A of 4 is equal to the previous number, I'm leaving a space for it because I don't know it yet, minus 7. Okay, so let's go find those numbers one at a time. So in this case, my previous number was -2, that goes in here. -2 minus 7 is equal to -9. Okay, I box it in because that's part of my sequence. I'm gonna box that one in too. A of 3, the third term in the sequence, is equal to this number before it, which is -9. So that goes in here. Minus 7. -9 minus 7 is -16. Box it in. A of 4, the fourth term in the sequence, is equal to the previous number, which is -16 now, minus 7. So that equals -23. Okay, so there's my sequence, and I'm going to write it out. You never really see a sequence like this. You want to see it in like a linear line here. So -2, -9, -16, -23. Notice how let's say I wanted to find A of 12, the 12th number in the sequence. Well, I would need to find A of 5, 6, 7, because you keep building, right? You need the number before in order to get the next number. So I would need to find all those numbers before I got to A of 12. So I'm not going to be evil and make you do that. I'm just going to have you do 4 numbers. Okay, so if you ever saw like find A of 100, well, you would be showing me 100 pieces of work to do that. Not that much fun. I'm going to show you next week a formula that you can just go ahead and plug 100 into, but this is not it. Recursive is one step at a time. All right, and your last example, and then I will stop talking and let you guys do these on your own. So this one says the first number in the sequence is 2, and then any number in the sequence is equal to 10 times the previous number. So A of 1 equals 2. That was given. A of 2 equals 10 times the previous number. So that's where 2 goes in. 10 times 2 is equal to 20. Okay, A of 3 equals 10 times the previous number. And if you want to go put 10 parentheses like we did up here where we just left a space, that's fine too. So the previous number in this case is 20. 10 times 20 is 200. A of 4 is 10 times the previous number, which is 200. That equals 2,000. Okay? If we wanted to find the fifth number, I'd plug in 2,000 there. 10 times 2,000, and so on. All right? So this sequence, here are my numbers. And you always want to write them out. 2, 20, 200, 2,000. This one is I didn't do it for this one. This one is a geometric, we're multiplying. We had a common ratio of 10 there. This one up here, we were subtracting 7, right? These went down by -7, so that was arithmetic. Whoopsies. Okay. Sorry, my handwriting is absolutely horrible today. Wow. Sorry about that. All right, and then on the back is your follow-up questions. So for those of you who have these printed, you can see them, but you can have them in front of you already, but listen to my instructions because I'm just going to walk you through some of these. For those of you who don't have them printed, no big deal. This is not a lot to write. Just write it down, pause me, write it down, and then I'm just going to give you a few quick instructions. So these 2 problems are similar to the ones on the front we just did, where you're going to write out the first 4 terms of your sequence defined recursively below. Okay, and sometimes when they use the word definition, like I'm going to talk about that down here, sometimes don't get tripped up by the wording. That just means that you have the recursive formula, okay? So make sure you show all that work. I want to see your A1, your A2, your A3, and your A4. I'm only making you find 4. I could make you find 100, which would be terrible. No, I would never do that to you guys. A1, A2, A3, A4. A4 with the same exact work as you see on the front, okay? I should see this kind of work, 4 steps. Okay, and then tell me if it's arithmetic or geometric for both. Okay, that's the first 2. The second 2 problems, so okay, I'm gonna go back here. Pause me if you need to write that. Moving on. Hopefully you pause quick. All right, the second two problems, so 3 and 4, you're going to now write the recursive definition or formula, okay? That means the same thing for the following sequence. So now I gave you the sequence and you need to write it. So you have the notes from Monday in front of you. Use them, okay? I'm gonna give you a quick little hint that we did this to help us write these formulas or definitions out. You can use that or you don't have to. It's just a little helpful trick. Okay? So, as always, email us if you have any questions. Thank you guys so much for tuning in week after week. You guys are amazing. We can't wait to see you all. We wish we could teach you at home, but this is the next best thing, I guess. So, thank you again. We really do appreciate your hard work. Have a lovely day.